Well, class, here we are at class 15, and a lot of what we are going to do today will come out of chapter 4 in your book. Let's first talk about what we've learned this far. First, we've learned about boxes. We've learned where to put them. We've used a couple rules like the 6-foot, 12-foot rule for living areas. We've used the 2-foot, 4-foot rule for countertops. We've learned where specific outlet types like GFCIs and AFCIs have to go. But what do we have to do next to make all of that work? Well, we have to run wire, specifically non-metallic sheath cable. In the industry, we call it Romex. And Romex is a brand name for non-metallic sheath cable, just like Kleenex is the brand name for facial tissues. So let's learn a little bit more about Romex. Romex has a moisture-resistant outer covering that's also flame retardant. It has at least 2 insulated conductors with the ground. And the wire sizes can range from number 14 up to number 2 for copper conductors. It also comes with a variety of number of conductors inside of the sheathing. If you have 2-wire Romex, you have a black, a white, and a bare ground. If you have 3-wire Romex, you have a black, a red, a white, and a bare ground. With 4-wire Romex, you have a black, a red, a blue, a white, and a bare ground. In Article 334-108, it requires Romex to have either an insulated or non-insulated ground wire. And today, you're going to find that it is always going to be bare. So what are the types of Romex? The code gives us type NM, type NMC, and type NMS. We will deal with type NMB. Now you might say to yourself, type NMB is not in the code. And that's correct. You don't see the B after any of those. However, we are using type NMB, and the B stands for 90-degree insulation. Older Romex conductors used to be rated with a 60-degree insulation. But due to extreme high temperatures in attics and underneath light fixtures, it became very brittle. I have replaced a lot of light fixtures in homes that were built before 1984, where the wires were completely almost disintegrated, at least the insulation. So why is 1984 significant? Well, in 1984, the UL required that all conductors within Romex to be rated at 90 degrees Celsius. And then the outer jacket, to prove that, has to be rated with the suffix B. That's where we get NMB. Now, you still have to use the 60-degree table to figure the ampacity of the conductor, but now you can use the 90-degree table for derating. And we will get into derating later into this video because now it is definitely required by the code. So how do I know what size wire is inside of that Romex cable? Well, the manufacturers have made it very easy for us. And so I have white, that's number 14. I have yellow, that's number 12. I have orange, and that's number 10. And then we go to black, which is number 8 through number 6. So now we know all about our cable. We have to install it. So where can I install it? Well, I can install it on circuits that are 600 volts or less. I can install it in dry locations. I can install it in a home. I can install it in a duplex. And I can install it in an apartment. I can fish it through masonry blocks, and it must be protected against physical damage. So how do I secure that Romex while I'm running it? Obviously, the code is not going to let us just let this wire run free inside of our stud cavities and up inside of our joists. If I look in Article 334.30, it gives us the rules of how we must staple our Romex. Those rules are, I guess, support our Romex, not necessarily always staple it. But we can use staples and cable ties and straps and hangers or similar type fittings that are designed for that purpose as long as they don't damage the cable We're going to mount those supports at 4.5 feet, at least not more than 4.5 feet apart, and within 12 inches of every outlet box, junction box, cabinet, or fitting. If we look at a cable like 14.2, it's going to be flat. And you see in this graphic right here that I cannot take a flat cable and staple it on edge. The code also says in this article 334.30 that we cannot do that. And then sections of cable protected from physical damage by raceway, we don't have to secure that cable inside of that raceway following these rules, as long as it's within side of the raceway. So if we're supporting our cables at 4.5 feet apart, what about if we start running through our joists or through our wall studs? We're going to run those through holes and possibly notches. Do I have to support it then every 4.5 feet? The code says no. At 334.30a, it says that if we're running horizontally through holes and notches, that we don't have to support it, and the holes will be considered our support. We still have to fasten within 12 inches of each box. Now, there is an exception with single gang boxes. Let's look at Article 314.17c in the exception. And that one tells us that we have to staple within 8 inches of a single gang box if we're not using a cable clamp. So if you have a single gang box, no cable clamp, you must fasten that Romex within 8 inches of that box. What about when I come around a corner? What then? Can I just 90 my Romex and make it tight, make it look really good? Well, the code also addresses that in 334.24. And that tells us that if we have type NM cable, we have to bend it so that it won't be damaged. And so the radius of the inner side of the curve or the bend has to be not less than 5 times the diameter of the cable. Well, how do we figure that? Well, generally, if you look at the cable, here's what I can do. I can use a soda can or a pop can, or even like a 16-ounce pop bottle, and whatever the radius of that is, that would meet within the 5 times required for our bending radius for that cable. So we've been talking about running stuff inside of walls and through, floor joists where things are going to get covered up by drywall. What about if it's in an unfinished basement and crawl space? Well, the code addresses that in 334.15, exposed work. C, in unfinished basements and crawl spaces. This article says that we can install our conduit through holes in the joist just like we would anywhere else. There is also an odd code that you may have not known existed, but it tells us that if we have 2 number 6 or 3 number 8 conductors inside of a Romex, we can install them directly on the lower edge of the joist. Now, I don't know about you, but that would be kind of weird. I mean, that'd be like running a number 8-3 that you'd run for your range on the bottom of the joist, just like you'd run conduit. Now, take a look at that picture here. To me, that just looks like sloppy work. Well, our codes in this area for the county of Sarpy and then in Douglas County and in Omaha, they do not allow us to do that, even though it's in the code. They have a requirement that's more stringent than that. This article also addresses, let's say we have to put a GFI in the basement or a sump plug in the basement or a washer plug or a plug for a refrigerator or freezer in the basement, and it's going to be exposed. Well, this article says that we can install that in a metal conduit as long as the metal conduit and the box are connected to the equipment ground, and that we secure the cable within 12 inches of where it enters the conduit or tubing. We also have to put an insulating bushing or some sort of adapter on the top of that. And you can see in this graphic here where they've done that. Now, we used to get away with just putting like 3 or 4 wraps of tape around the top, letting the tape extend past the hole, and then just pushing the tape down in the hole. They don't allow that anymore, but you can get pound-on bushings for your pipe that would meet the requirements of this code today. The last thing that I want to talk about today is derating. Now, I know that we've always looked at derating as far as inside of a conduit. So where does derating apply when we have Romex? Let's look at 334.80 to address that. In this code article, it tells us that the ampacity of type NM cables shall be determined in accordance with Article 310.15, and the allowable ampacity shall not exceed that of 60 degrees for the rated conductor, and you can use the 90-degree table for ampacity adjustments. It also tells us that where two or more type NM cables containing two or more current-carrying conductors are installed without maintaining spacing between the cables, so they're going through a hole or an opening, and this opening is to be sealed with thermal insulation, caulk, or sealing foam, the allowable ampacity of each conductor shall be adjusted in accordance with Table 310.15b3a. And then it also tells us that where more than two type NM cables containing two or more current-carrying conductors are installed in contact with thermal insulation without maintaining spacing between them, the allowable ampacity of each conductor shall be adjusted in accordance with that same table. That would be running through walls that have insulation. That would be bundling your wires in an attic that has insulation. So in that case, if you have at least two and you've bundled them together, then you're going to have to apply the demand factor. The code also tells us that if we have these cables, that both conductors count as current carrying conductors. Or I should say the neutral counts as a current carrying conductor as well. So let's look at having four number 14 twos through the same hole in an outside wall where there's going to be insulation. So if I have four 14 twos, that means I have two current carrying conductors apiece. 4 times 2 is 8 current carrying conductors. If I look at our table, it says that if I have 8 current carrying conductors, I can be at 70% of the rating of that conductor. Well, our code article told us that we can use the 90-degree table. So if I use the 90-degree table, our number 14 is good for 25 amps. So if I take 25 amps times 0.7, which is 70%, I'll get 17.5 amps. The code also tells us that I can't put larger than a 15 amp breaker on a number 14 conductor, so it still meets the requirements of putting a 15 amp breaker on that circuit if I have 4 Romexes going through the same hole. Now here's the thing, if I put 5 going through the same hole, now I have 10 current carrying conductors, which puts me at 50%. I'd be at 12.5 amps. And I no longer could put a 15 amp breaker on that circuit. So keep that in mind when you're running cables. I've never put 5 14 twos in the same hole anyway, so I don't think that you're going to have problems with that. That's all I have today for the video. We'll go over a lot more of these items in class. I want to answer your questions. So if you have any questions, please write them down so that I will be able to answer those questions for you and somebody else in class who may have not wanted to ask the question themselves. Remember, the difference between somebody else succeeding and not succeeding could be the question that you weren't afraid to ask. Well, that's all I have for now. I hope that you took notes, and if not, go back, rewind a little bit, and write down all of the most important things of this video. Once you do that, have a great rest of your day. I'll see you next class.